Hi everyone, this is Ibrahim Siddiqui. I'm very excited today to show you another video about this series of revolutionizing project control, leveraging control theory for integrated cost, schedule, and risk management. So in this video, I'm going to show you an example on what we have, numerical example, of course, on what we have uh, demonstrated in the previous video for the the mathematical formulation of the utility function or satisfaction, and the XCE, which is the adjusted cost or actual cost or forecasted cost. It all depends on which angle you are looking at. So the mathematical formulation for the satisfaction, we said that it depends of the variable x, which represent the cost, and the risk tolerance RT. And also we said that this utility function or satisfaction is bounded between 0 to 1, and the cost x is also bounded between high cost and low cost. Sorry, it should be low cost and high cost. And okay, so now we have this numerical example. Someone give you a budget, say 4,500, and he suggests that the risk tolerance is about negative 300, and the payoff 500. By the way, there is a way which we are going to see it in the next few videos, how to evaluate the risk tolerance and the payoff age. So this implies that high cost and low cost, the high cost is basically your budget x0 plus h, and your low cost is x0 minus h. So by substituting these values, risk tolerance and payoff, you can expect that the the utility function, so which it is bounded from 1 to 0 and low to high, and it will be somewhere something like this. Okay, so this is high, and we say this is half, and the budget will be somewhere here. Okay, and this is h, and this is h. Okay, so and also we said that this curve will intercept at the utility function when it is half, and you get this value XCE. By the way, I'm going to show you another example using Python if you stay with me to the end. And I am okay, so we get this expression. So we know the formulation of the XCE, which also depend of risk tolerance and the higher cost and the lower cost. So if you know the lower cost, the high and the end, and then you know the risk tolerance, you can evaluate your actual cost basically. And also we said that if risk tolerance is negative, then it suggests that this is risk averse. Okay, that's why it's concave. And then if risk tolerance is positive, this will suggest that the risk is seeking or loving. And if risk tolerance goes to the infinity, means it's very, very large, that the risk is neutral. Okay, so And then if risk is natural, for example, then the XCE will equal to XCE will equal to X0 because it's natural. And if positive, if risk positive means it's risk seeking, and the curve will be convex. So for risk averse, will be concave. And for this example, because we have risk tolerance negative, it must be concave. So we substitute all the values that we have, and then we get the certainty equivalent or the adjusted cost. And you can see it is less than your budget, which is 4,500. Of course, because you are risk averse and you have a negative risk tolerance. All right. So, and the expected cost variation, which is delta x equal xce minus x0. I think here there is a mistake, so it should be like this. So okay. So and here you get negative sign. So the cost variation or the risk premium will be less. If you add this value to your actual, you get your original budget. Because you are risk averse, that's why you went a little bit down. How much down? This value. Why? Because you have a risk tolerance negative 300. Simple, very simple. So the systematic risk, if you remember last time, I define the risk tolerance is the range of your high cost and the low cost, and then you time it by a systematic risk beta. And this beta, it will have its own video that I will explain it in detail. And we said also that H and low, X0, etc. So if you substitute this, you get 2H beta. Now you can, this equal minus 300, okay? And you can evaluate your systematic risk for that particular budget. Okay, so now I'm going to show you, let me see if I can do this. Yeah, so now I'm going to show you a simulation in a Python. Let me increase the size. At least you can see, I'm not sure if you can see this. Okay, so I am in, I'm using a Python language. It's very easy, simple, and you can do a lot of things with it. And I'm going to build a small simulation on what we have said just now. So first of all, you need to import libraries. And I'm importing 3 major libraries here. So the NumPy, which is numerical Python. This is where you get all the algebra, numerical, I mean, all the basic math that usually we do it in our calculator. And I will call it NP. I will call this NumPy as NP because I don't want every time type NumPy. I will just type NP. Get me cos or square root or something like that. And then I will import the matplotlib, particularly the pyplot, and I will call it PLT. These are convention, by the way. So PLT, NP, PD, and so on. This library is important because we want to plot curves. As I showed you previously, so I was talking about concave, convex, the utility function, and so on. So, and then because I want to do, I want to simulate, I want to change the numbers. So there is very interesting library here called IPY widgets. And the same thing from IPY widgets, I will do the interaction here. Okay, so then I will execute. You can execute by doing Shift Enter. Okay, so it's working now. I can see it's one. Everything looks fine, and here I am going to define my utility function. Based on the previous example, what we need a budget x0. We need the payoff, which we said it is 500, and we need the risk tolerance, which we said minus 300. But I want to make this variable, so I want to change it to play with it. All right, so I define a utility function. And then I will calculate the utility and satisfaction and payoff, all of this. So we said that the high cost is a budget plus h, which is x0 plus the payoff. Low cost, the lower boundary of the cost, it is x0 budget minus h. And we compute the forecasted value, the risk premium, and systematic risk. Forecasted value, we said, is the adjusted cost or certainty equivalent or your actual cost. As I said, I keep repeating this. It all depends on how you are looking at the scenario, at the situation. So the risk premium, which is your cost variation, which is XCE minus the budget, XCE minus X0. And beta, just now I showed to you how we can calculate it based on this scenario. But beta will have its own video. It can be calculated statistically. And then I will prepare, we do something to prepare the graph. So I will generate X values. Keep in mind that X represents the cost. So I will call NP, which is the NumPy. There is this, how they call it, lean space between, it will create, but basically will generate 1,000 points, okay? And we calculate the utility response, which is the utility function or satisfaction. And I demonstrated to you last week, which is x exponential x minus h over risk tolerance minus 1. You divide it by the exponential of low minus high divided by risk tolerance minus 1. And also we said for the risk neutral, when the risk tolerance goes to the infinity, large risk tolerance, so we said that it's a high cost minus x, a particular x, divide by high minus low, which will be linear here. So the first one is exponential, and this one will be linear. Now I will plot the satisfaction response. So I will choose, I will call PLT, which is the matplotlib. And then I plot on the X for the utility and the XU neutral for the, if it is a neutral, I will just specify the color. Very easy, I mean. And then here I will, this is just cosmetics here, the title, label, legend, and so on. And then I will calculate the values when I change it. This is the interactive slider. I will define a float slider, and between 100 to 1,000, I will just put the limit here, and I will create the interactive plot. So I guess I did not, let's validate this first, if it works. Yes, perfect. And I will do the second one. Perfect. And here, okay, so now I got I got the curve. So as you can see here, so I have, this is my default. So I have my budget X0 4,500, my payoff 500, and my risk tolerance negative 300. So the did the math for me and gave me the XCE, which is 4,197. It is expected because we said it is because it's negative risk tolerance and the risk premium. This is exactly how I show you previously, and the systematic risk based on this scenario. Now assume that, and yeah, you see the curve here. So this is 5,000 and 4,000 between low and high cost, and then 4,500, I guess. Yeah, 4,500, which is here. This is the X0 here, and my utility function. Now I can build my utility function. Okay, the blue dashed curve, and you can see the XCE is 4,100, almost 4,200, and it is exactly almost 4,200. So now let's simulate. So if I, for example, I will increase the risk tolerance. If I increase the risk tolerance, it means that I am going towards risk neutral. So if I say now 800, so you can see that the forecasted value now is, different than the previous one. It's going to 4,500. And you can see the curve here. Okay, and we said that the curve is dictated by the risk tolerance, and because it is negative, that's why it's concave. Now if I change the sign, let's say bring it previously, yeah, 300, and then you see here, now it become convex. It become convex, which means risk seeking or risk loving. However, now the risk premium is 300. It's the same value, but in the positive side. So the XCE now is higher than your budget. So if you come here, you see 4,800, right? So the risk tolerance really play a big role here. It's very, very sensitive. Now, if I increase, let's say 800, you see, it's the curve, the concave, the convex, or the risk, because I'm in a risk seeking here, it's a positive sign. So I'm going towards to be more risk neutral. If I say 1,000, yeah, see, if I say 1,200, it's decreasing. So I am more going to my budget here. If I go larger, so you see, so it's almost I'm going to my budget. So which means my XCE will equal your actual cost equal your means what you plan for, what you budget for, what is your what you spend, your actual cost exactly what you budget for. Why? Because you had high risk tolerance. Okay, and which means your systematic risk is very, very high here. Later on, I will show you with something which we call it risk attitude sensitivity factor based on the stiffness of the project team. But this it's another video. But I'm just giving you high level um, um, outcome of what will be in the next presentation or videos. Okay, so let's now let's say I have high value of risk tolerance, but with the negative uh, sign. It will always be almost risk neutral. See, 4,418, almost 4,500. So if I keep increasing, let's say 115,000, so you see 4,009, very sensitive. Now, if I reduce it, it used to be 300, right? So this is by default. So now if I reduce it, say 100, you see, it become very, very large. So and then if I take negative, positive, you see here. So which means your cost variation will be very high because your tolerance to the risk is very, very low. So that's why you have higher risk premium. You have higher cost variation. So, and then it will be the same thing. And then if I keep, say, I put just 10, it's almost the maximum. You are reaching the maximum value here. So if I do the other side, say negative 150, for example. Yeah, so because it is negative, you are in a risk averse region. So now if I want to decrease my payoff, say now I will put 200. So you see here, because you have 4,500 plus 200, you get 47. And similarly, when you go low, and you see here. So now if I keep the same risk tolerance, so you see the risk premium, it's changing. So this will tell you that the low cost and the high cost are very sensitive. It's not only risk tolerance. I mean, there are many factors here. You have the risk tolerance, the attitude, the payoff, the systematic risk, and another factor which we are going to discuss it next time, the risk sensitivity, risk appetite sensitivity factor (PSI). Hope that you like this video, and next time we will deep a little bit further before we go to really interesting stuff, pure mathematics in project control. Thank you very much, and see you soon.